So, okay.
Starting the
Great.
recording, maybe
Perfect.
a little early.
And then we're going to share the screen from the Zoom here, right?
Yeah, so Gio will have to share the screen.
I mean, I think I can do that here. I'm already.
Oh, you're already controlling.
Yeah.
You're in.
Mm-hmm. Okay. So everyone should be able to see the system workstation now.
Yeah.
Okay. And give me 1 second here. Okay. So I'm going to grab here our Zen 3.4. And I usually like to start the training with a very brief overview of the physical aspects of the system. However, you're probably already familiar with it since you do have a Z1 already. Maybe all I'll mention is the system, the AxioScan 7 will be the same in terms of loading your slides, loading the samples. Those workflows haven't changed. The trays are the same. They're interchangeable even. So you could go from tray from one system to the other with no issue. I will mention maybe a very brief overview on power cycling of the system, since I think that's an important thing to note. The AxioScan 7, the same as the Z1, is fully automated and controlled by the system workstation. So it's very important to ensure proper connection in between the microscope and the computer. Most of the issues that I've seen are usually a miscommunication in between the microscope and the computer, and they'll go away after a full power cycle. So the full power cycle of the system will include first closing the software, closing Zen. Then after that, you want to wait for the little microscope icon to go away, which if you're familiar with it, it's the little service tool that represents the connection between the microscope and the computer. It sits right here on the desk, the desktop bar. And actually the system is on right now, right? Is the microscope on?
Yes.
Okay, so I can go ahead and open Zen, and then we'll see that little microscope icon come up. That way you can see what I mean. So we're going to open here this Zen slide scan application. Okay, so here it is. This little icon right here, this little microscope, Zen service, represents the connection between the microscope and the computer. So when doing a full reboot, again, you first want to close Zen, then you want to wait for this microscope icon to go away. It'll go away by itself. And then you can turn off the microscope, which you would do by first pressing the round button on the front, then the hard switch on the left side of the system, and lastly, the power strip that is labeled with the microscope system. That will be a full power off, including the power strip. I do recommend that you do a full power off on the weekends if it's not being used, or if you notice that there are some miscommunication issues. Sometimes it'll say something like a camera timeout error. That is typically due to something not quite communicating properly with the system, and it'll go away with the full system reboot. You want to wait about 1 minute before doing everything in reverse. So first you would turn on the power strip, second, the hard switch on the left side of the system, third, the circular button on the front, And then you're going to wait for the system to initialize. It'll do a few procedures. You'll hear it whizzing around. And when the status indicator light turns green, then it's okay to open the software again. You do want to wait for this green light before opening the software, again, to ensure that the microscope fully initializes so that it is ready to connect to the software. Okay, very easy. And that's it basically for power cycling. Then with respect to loading slides, it works the same as before. I will note, however, that before you didn't used to have this very handy tool that you now have. It's this little black instrument that's sitting right on the bench. It'll help you load 4 slides at a time very easily without having to manually open those slots that you used to do with your thumbs before. You basically just place the tray on that little tool. And when you press the lever down, it'll open all 4 slide positions. That way you can load 4 slides at a time very easily, very quickly. When you release the lever, then that releases the tension from all of the springs and they close again. So that'll be a more efficient way to load in your slides now that you have that tool. Okay. You can still open the door either from the software right here or from the button on top of the door. That's the same as in the Z1. All right. Now let's take a look here at the new Zen 3.4. So you're going to notice here a few differences. So again, this is Zen 3.4, the new version of the software. You still have the magazine tab, which is a representation of all of the slides currently in the system. And you still get a few details here for each slide. Let me see if I can make it a little bit bigger so that we can all read this from our screens. I'm going to increase our workplace zoom here. That way we can all read this from our laptops. Okay. Let me hide this. Okay, there we go. So in the magazine tab, we have a representation of all of the slides currently in the system. This gets detected automatically. All slides are automatically check marked for processing. This means that they will get scanned. If you're not ready to scan them yet, maybe you want to optimize your scan profile for the slides, then you can always unmark them. And then if nothing is marked, then if you click on start scan, nothing will happen because even though there's new slides in the system, nothing is check marked for processing. So that's what this first column here means. You also have your slides here organized by tray position and by slide position. So that's what you see here. This is the slide position within the tray. You get also a slide overview, which will update as you preview or scan your slide to tell you what that slide contains. Then the next column over here is the scan profile selection drop-down menu. So this will allow you to select the profile that you want to use to scan your slides. Again, the profile basically contains all of the information about how to scan that slide, being either the course focus, the fine focus objective, the channels, if it's fluorescence, the exposure times, everything that's needed to know how to scan that slide. So that will be selected here from the drop-down menu. Then we also have the scan status here, which will update as we work with the slide. Obviously, these slides are new. And then you have a space here for the image file name. And you can also choose to do either the automatic naming definition, which is what's done by default, or you can always manually assign a name to your slide. If you know exactly what it contains, maybe you might, put your name on it if you want, or maybe you might want to put in the specific application, whatever tissue it is, just so you can identify where your slide is saved and the name of the file. So this is just a manual naming, definition. You can obviously still use the automatic naming condition, which is what's selected by default. And I'll show you a little bit later the options that you have to customize those automatic naming definitions if you're scanning a large batch of slides. Okay, so far everything is very similar to this one over here. Up top, we have, you already saw how this works, the mark and unmark button. This marks the slides for processing. You also see that this AxioScan window here now updates to let you know how many slides are in each tray and how many are going to be scanned. So there's a new feature here that will help you identify how many slides you're scanning in total. Then you also have here the button to expand all or collapse all the trays. If you have a lot of trays in there with a lot of slides, it can get pretty busy. So this can help you work with a few at a time. Now at the top here, you have your global scan profile. So this will allow you to select the profile that you want to use for all new slides currently in the system and for all new slides that are going to be loaded into the system. So if you already know the profile that you're going to be using and you're loading all of the slides that you want to scan with that profile, you can easily select it here and it will be the default profile assigned to all of those slides. Lastly, you have a smart profile selection wizard button here. Honestly, I don't use this very much. This will just help you build a profile from scratch. But my recommendation is always to start with one of the default scan profiles and then modify those and save them with your own name as you optimize them for other applications. And today we will be behind. There's already a couple of default profiles here for Brightfield. We're also going to work on a default fluorescence profile that you can use to start with. Any questions so far about the magazine tab and what all of these options here mean? Okay, so now we have here on the left side our Zen Blue tabs. These are going to be very familiar for you if you use other Zen Blue systems. The particular one for the AxioScan is again the Scan tab, and this is where you're going to spend most of your time when scanning slides. You might also come here into the Processing tab with some frequency. This is where you're going to come to do shading corrections, to do restitching of your image, to export your files as JPEGs or TIFFs, to maybe do an EDF on a Z-stack or deconvolution on a fluorescence Z-stack. All of those are processing methods that you can search for and apply for in this window. But again, for the most part, you're going to be here under the Scan tab. So here we have, again, the AxioScan window, which contains a representation of all of the slides currently in the system. So we have 25 trays, and the first 3 trays have some slides in them. We can also open the door here from the software, as I mentioned. And then we have our naming definition window, which is the automatic naming convention for all slides currently in the system. So we have a few preset options here. If you have a barcode on your slides, you can use the barcode to save the files. If so, you want to activate this option in 2 locations. You first want to make sure that your profile here has the option activated to recognize barcodes, and I'll show you where to do that. And then you also would want to have your barcode here in your naming definition. So you have a couple of preset options here that already have that barcode incorporated. If you don't have a barcode, then you can use the date in an increment or the date time and increment, which will output a file with this file format name. If you're scanning a lot of slides, this string of numbers can quickly become a little bit meaningless and hard for you to find your data. So you might want to create a custom naming definition if you wish, which you can do that by opening the options menu and going into new. And let's say, for example, that my application was this mouse brain samples. So I'll just call that like that. And here it'll open a window where you can select your custom automatic naming definition. where maybe we don't care about any of these formats of date and time and ink and whatever, maybe all we care about is a prefix. So again, if this is mouse brain, we could do mouse brain, and it was, let's say, mouse XYZ, whatever. And now this will be your automatic naming definition that will be applied to all the slides currently in the system. So this will be a good way for you to create a custom naming definition to name your slides if we're gonna scan a batch of slides all from the same application. Okay, I'm gonna delete this dummy one for now, but you can always create a new one right here. Then we have our storage location. This is where you're going to choose where to store your files. You want to make sure that you are always saving to the D drive and not to the C drive, and that you create your own folders and subfolders as you see fit to make sure that you know exactly where you're saving your data and that you're not accidentally saving data into some other folder and then you can't find it later. So definitely be very diligent about this. And then lastly, we have the acquisition monitoring window, which will give us a quick sneak peek into a current scan as it's scanning. I'll show you how that works a little bit later. Okay, any questions about the scan tab over here or the magazine tab? No, okay. So now let's go into our scanning workflow. So this is going to be the steps that you would take to scan a slide once you have a profile that's already working for your slides. And Holly, maybe you can help me identify what these slides contain.
Yeah, so the first one I think is the Zeiss, one of the calibration slides. The second
like the rat kidney H&E?
Yeah, I think it's a Brightfield one. The second one is an H&E, and then
Okay.
the third tray is Fluorescence. And do you know what?
Yeah,
DAPI
488,
488,
564,
564,
and 637,
And
647.
647.
Okay.
Yeah, so that one will be our Fluorescence, four-channel Fluorescence.
Okay. So let's start with the Brightfield, and sure, I mean, let's start with your own sample. That I think that's always better. I created a couple of standard generic Brightfield profiles that will hopefully work for a lot of your own Brightfield samples, including H&E, IHC, trichrome stains. As long as it's imaging Brightfield, these two standard profiles that I created, one at 10x, one at 20x, should be a good starting point for them. Let's assume that it's already optimized for this application. I'll show you the scanning workflow for this particular slide. So maybe I'll also do it with the first one here that we know works. So this is going to be a full 6 steps to scan a slide. You can condense this into less steps later on as you see fit, but I'm going to go through the full 6 steps so you know all of the options available to you. The first step is always going to be to choose the profile that you want to use to scan your slides, which you can do either individually for each slide from their drop-down menu right here. You can also assign it to a group of slides by highlighting them, and you can press Control or Shift on your keyboard to highlight multiple slides. And you can right-click and assign a scan profile to that batch of slides. Or you can always select a global profile again for all slides currently in the system. So that's step 1. Step 2 is going to be to choose your naming definition, which you can use one of the presets. You can create a custom one, or you can create a manual name for each if you wish. Step 3 will be to choose your storage location. So you're going to go in here and maybe create your own folder and subfolder by name, by PI, by project, however you want to organize your data. And then step 4 is going to be to create a preview scan by clicking here on Start Preview. When you click on Start Preview, the system will start with the first tray and take it to the preview area of the Axio scan. This is not the scanning stage. It's just a preview area in the front with a few LEDs and mirrors and a quick camera that takes a quick picture of the slide. And based on that picture, it captures the label and what the slide contains. So this is the preview. And as you can see here, we have our label and also the tissue that is in the slide and the automatic tissue detection that you can see with the green boundary. So that was all captured by the preview. Because I had 2 slides here selected, the system then went on to grab the second tray and also preview the second tray as well. So that was step number 4. Step number 5 is an optional step, and it's to go in and check the automatic tissue detection and make changes to the automatic tissue detection if we don't want to scan the entire tissue sections. So let's go in ahead and and I'll show you how to do that. So you would go here into the options menu and select here the checked and correct sample detection results. So again, this is step number 5. And it allows us to visualize the preview and what the system detected automatically as my tissue in this green boundary. Here we're using automatic tissue detection. So the system is automatically finding the sample based on this thresholding that we see over here. This threshold is based on the actual preview picture. You can also see that same histogram display down below. So this histogram display down here corresponds exactly to this same histogram display here. The difference is this is just for display purposes. We can even enhance the display if needed. Maybe we want to see more contrast. If we wanted to see, we needed to maybe capture this sort of thinner, fainter tissue, maybe some adipose tissue over here. So this could help us here. But really where we are doing the automatic thresholding is on this left side. If you want to change the automatic thresholding, you can by just moving these bars. And as you move the bars outside, you're going to basically open that thresholding. And here on this side, these are our lighter pixels. So as you can see, as I open very carefully, a few clicks at a time, I start capturing more of those lighter pixels in my segmentation. As a rule of thumb, the last peaks that you see over here are going to be our background. So if I open beyond that, I'm not going to really detect everything because I'm actually detecting everything. So here I'm including the background in my selection. So obviously everything would be selected and I can't discriminate where my tissue is. So as a rule of thumb, you want to be just under that peak. And that means that we're going to be excluding our background and including our tissue. So that's almost exactly at the peak where you can see that we're also selecting these very light regions because we're right on that border. So to avoid having that issue, usually going a little bit further in is a good place to be so that we can actually select our tissue nicely. However, if your tissues are a little bit more faint, then giving yourself a little more room here will help you capture those sections. You also have an option here to delimit your selections based on their size. So if they are smaller than 3 millimeters squared, they're going to be excluded right now. This is sort of the default for most standard applications. However, you might have some applications where maybe you have organoid sections, or maybe you have some very thin tissue sections. Those might be smaller in area. So maybe you might want to change this to 1 millimeter squared or 0.5 millimeters squared or 0.1 to make sure that you can capture those smaller sections. The compromise is that you might start picking up some artifacts, right? Now I'm picking up this border right here of my cover slip, which is easy enough to get rid of either by adjusting my threshold a little bit more or by just grabbing it and literally just deleting it. So again, these are all changes to my automatic tissue detection. I can also manually make changes to the detection. So let's say that I didn't need to scan the whole tissue section, but only a part of it. what I would do is turn off the live update so that I don't update my automatic tissue detection. And I can make some modifications to my selection here. I could start by saying, okay, maybe I want to scan only half of this. Let's say the left side. I can right click on my shape and I can click here on split. And that way, if I click on one side and then I right click on the other side, it splits this into two sections. And I can always say, okay, I don't need this section. I can delete it. And now I'm only gonna scan this part. So that can be useful if you don't need to scan the entire section, but only a particular region. You can split it like this. You can also use the cut tool, which is very similar. The difference is with the cut tool, you want to enclose the area that you want to cut. So you just enclose it like this. And when you right click, that section will be deleted. So those are two different options. If you want to only scan a particular region of your tissue, you could also do the opposite and add regions that you want to scan. So for example, you can say like, okay, no, I really want to scan this part over here along with this one. So the easiest is to just draw a shape in here, and then you can press Control on your keyboard to select both of them, and then you can right click and then you can merge those two shapes. So that can also be a very useful tool if you're having issue with maybe this fainter selections, right? Maybe you want to capture this adipose tissue over here, but you don't want to bother with the automatic thresholding because it's so faint. Then maybe drawing it like this would be the best. And then you can merge the two to make sure that you scan the entire thing. Last thing I'll say here is if you take your time drawing a particular shape, and you have serial sections, there's a good chance that they're all going to be approximate in shape and size. Control-C, Control-V, copy-paste. It also works here in Zen. So you can also copy that section into another region, and maybe you might need to rotate it a little bit or skew it or resize it. But essentially you save yourself some time because you already have your complex shape that you drew, and you can just copy it into your next serial section. Or alternatively, maybe all you need is one particular ROI, and then the simplest thing is just to draw a square. I will mention that if you are drawing regions, to be careful and not draw a lot of empty space. If you draw something like this, your focus might fail in the borders here because you might be losing focus points that are going to fall on these empty regions. So I always recommend using either the polygon or the spline contour to draw much closer to your sample if needed. And this is true both for bright field and fluorescence applications. If you draw with one of these shapes, either spline or polygon, if you want to make some corrections, you can always right click and edit points. That way you can make sure that you actually have your selection properly created if you want to. And you don't have to be super exact here, but I'm just giving you, the options. You don't, what you don't want to do is, have something like this where you have a lot of empty space. Okay, any questions about how to adjust your tissue selection either automatically or manually?
I actually have a quick question.
Yes.
That you may already have sort of gone over, but I usually manually go around my tissues because I'm doing serial sections, but they do change because it's serial sections across the mouse brain. And how much background is going to be problematic to get into your image? Do you want it like right at the image line, the slice line when you're going around the image? Is there any guidance there?
So I would recommend using this spline contour or the polygon contour. And if you go around, and you don't have to be super extra careful, I'm sort of just going around and clicking on the borders, and then it sort of automatically creates this, contoured shape for me. And when you right click, you close the shape. And I would say this is probably good enough, even though I have a little space here, like that's okay. What would be problematic is if you were like maybe over here, when you are scanning at 20 or 40x, there's definitely quite a few tiles that are gonna fall in here, and then my focus routine might fail. So in that case, I would recommend trying to get a little bit closer to that border if necessary.
Okay,
Does
cool.
that
Thank
answer your
you.
question?
Yeah, it does. Thanks.
And again, something that's very useful again is you can always right click and edit points, and you can manually move some of the points here, or you can insert more points if needed. That way you can make small corrections. And once you have a good outline that works for one of your serial sections, again, you can always copy paste and take that into your next serial section. And maybe now you only need to make a few small adjustments to that new shape. Okay, I'm going to revert this back to the automatic by just reactivating my live update, and now it'll rerun the automatic tissue detection for me. I'm going to revert this back to 3 millimeters, so we don't have these little artifacts popping up. And the second part that you can do here that is new with Zen 3.4 is the ability to check, verify, and edit focus points. So you can do that for both coarse and fine focus down here. So you click on coarse focus, this will show you the 2 coarse focus points that we're creating, and then the multiple fine focus points that we're creating. This can be very useful if you're having problems really getting, very close to your sample with the outline. You can always grab one of those focus points that might be falling off and then bring it back in. So make sure that will make sure that you don't lose that focus point and that it doesn't fail. This is also very useful if you have tissue sections that have non-continuous regions. So maybe imagine like an eye section that is basically pretty empty inside, and what you care about is maybe on the outside. This will be very useful, so you can move around these focus points as necessary, so you can make sure that they fall on the regions that you actually want to scan. Once you're happy with your tissue detection and the optional feature to check your focus points, you can go to the next slide. And then you can basically repeat the process for this slide if you want to make some adjustments. So obviously for this slide, I haven't looked at it before, but it looks like it's working pretty well from scratch. I can probably get rid of some of these regions here by adjusting my thresholding here. These stains are pretty dark, so I think something like this could be, a good setting for them. And here we also see how the cut or split option can be very beneficial if one of your tissue sections is right on the border here, and it's sort of joining in with this excess mounting media or whatever it is with the edge of the cover slip. Again, you can always right click on this, and then you can split these 2 sections right where you're gonna end this here. And that way you can delete this region that you don't need and keep behind your actual tissue section. Once you're happy with all of them, then you can click on finish. And that would be the conclusion of step 5. And then for the final step, I'll just do it for this one slide, you can click on start scan. So when you do that, the system will now grab that tray, take it to the actual scanning stage, and start with the coarse focus, fine focus, automatic shading, and then scanning. So again, the full 6 steps were to first choose the profile that you want to use for each slide individually, for a batch of slides by selecting them and going into the context menu, or by choosing them from the global profile. Step 2 was to check our naming definition. Step 3 was to check our storage location. Step 4 was to start a preview scan. Step 5 was to go into our options menu here and check and correct sample detection results to adjust the automatic tissue detection and the optional feature of checking our focus points. And step 6 was to start the scan. This 6-step workflow can be condensed If you have already worked with your samples and with a particular profile, and you know that the tissue detection works great, and you want to scan the entire region and you don't need to verify your focus points, you can skip the preview scan and the check tissue detection steps, and you can condense this into 4 or even 3 steps. And those would be, you still want to make sure that you choose your profile. So that's always going to be step number 1. You might go with the automatic naming definition as is. So maybe you could skip that step. I do recommend that you always check your source location. So I always recommend to keep this as step number 2 at least, if necessary, just because again, you can always by accident save in someone else's folder and then you lose track of where the data is. But then you could go straight from here to start scan. So that would be a condensed, essentially 3-step workflow. When you do this, the system will still acquire the preview for you. It will still do the automatic tissue detection. It just won't wait for your input. It'll proceed with the scan with whatever tissue was identified here. Any questions about the 6-step workflow or the condensed 3-step workflow?
Anita had a question about the where the T1S1 dash Zeiss.
The name for that profile?
Where the name, where this came from and this.
Yep, definitely. So this is new with Zen 3.4. Before, it used to be that if you made changes to an existing profile, the name of the profile would change to adapted _ whatever profile name. Now, instead of having that adapted, we have the tray and slide that this particular profile was modified for. So because I went into the tissue detection editor and I modified my tissue detection from the default in the profile, right? I made some changes to the thresholding. I made some changes to the tissue size region. For this one, I made some changes here. I cut one section out. So this is telling me that I have adapted that profile. And if I wanted to, I can save it as a new profile that is going to have this convention here for tray 1, slide 1. I can either choose to save it and it'll have that new name. If I am working on my own personal profile that I've worked with, maybe I might add my name to it so I know that I worked with it and that this is mine. Then I could also just save it as it is, and I'll save a new profile with this name so that I know that is my profile. Okay. And if I have worked with it before, I could always override that profile. So say that I've already, I made a few changes, but I want to keep these changes going forward. I can always delete this adaptation, save it, and then it'll ask me if I want to override it. And if it's my own profile, then I could override it and it'll be now saved to be used for all other slides. Does that make sense?
Cool, yeah.
Okay. All right, so this slide is finished scanning, so we can double click on it to open the file. We see here our image. We can easily adjust here our background a little bit so that we don't see those gray edges. It's very easy. Just slide this display adjustment here towards the left until you find that last peak. And then that hides that background. So now we have a nice white flat image. That is completely normal. This boundaries always obviously contain data, while these edges over here don't have any data. So obviously, there's always going to be some shading there, but you can always hide it very easily. And then my favorite way of exploring data to make sure that it's in focus is to open the navigator. That way I can remind myself what I'm looking at. And I have an overview here. And then if you press F11 on your keyboard, this will take you to full screen mode, so that then you can use the scroll wheel on the mouse to zoom in into particular regions of interest and confirm that the scan came out nicely in focus. When you zoom in, you'll see your zoom factor here increasing. You can go to 100%, which is going to be the native magnification of the scan. So in this case, this was a 10x, so 100% would be our 10x field of view. You also have here this icons for each objective. So you can always say, okay, I want to view a 5x equivalent field of view. You can just click on that. And this obviously corresponds to 50% zoom of your file, right? And so on with the other ones. So typically I'll go either at 50% zoom or 100% zoom. And you can always just use the navigator to click on a few different locations. That way you can verify that the whole scan came out nicely in focus. You can always digitally zoom in beyond the 100% zoom. So I can go here again to 100% zoom. And this is again the native magnification of the scan. But if I wanted to, I could always go, maybe let's go somewhere over here, see how this looks like. We can always go click on the 20x. You may notice that the image might start getting a little bit blurry or a little hazy. That's because we're not digitally zooming in, but we can still see a lot of detail here. So, you know, maybe this level of detail might be enough depending on your application. Okay, now let's say that we want to add a scale bar. Let me exit full screen. If you want to add a scale bar or do some annotations, I'm gonna move this here to the side so we have a little bit more real estate in our software view. We can just go under graphics and here insert scale bar. By default is this red color here, but we can always right click on it and format the graphical element. That way maybe we might wanna make it black, maybe we might wanna make it a little bit thicker. Same with the font size. Let's make that black. Maybe let's make it bold. You know, maybe that's what we want to have. That's up to you. This will obviously be automatically created depending on the zoom ratio that you have. You can always adjust the size here a little bit if you wish. You can also do some annotations. So you can do arrowheads. You can change the color of those arrowheads in the same way as before. You can also insert text, so you can do some annotations here. And then you can also draw areas. And the cool thing about drawing areas is it'll do also a quick measurement for you. By default, we're measuring the area and intensity mean values in this region. You can also select other kinds of measurements as well. Like intensity min and max values, for example, or total intensity values. So this could help you do some quick quantification of particular regions of interest. This works for both bright field and fluorescence. For fluorescence, you're going to get those intensity mean values on a per channel basis. You can get even more detailed with this. So obviously for an area, maybe that could be useful. But maybe you're really interested in a particular region of interest, right? So I'm just sort of zooming into one of these, and maybe you can use this circular tool instead, and then maybe you might have a more accurate measurement for that area, again with intensity and area. Or you might even, you know, draw one of these spline contours again to really follow the particular shape that you want to measure. This could be useful if you want to do like, you know, single cell measurements, or if you want to, you know, get some quantification out of clusters. Maybe something like this. And then you have your measurement here. If you draw multiple shapes, I'm just going to draw a few other ones over here. If you draw multiple shapes, these are all going to appear under the measure tab. And then you have all of the measurements that are drawn in here with their area, with the intensity mean. And again, you can get other measurements from here if you wish. And that way you can export this as a table and then grab some quick data from your images. All of these changes that I'm doing here on the data, or I should say all of these drawings, they are not changing the data, they're just layers on the data. So if I am done with this, if I don't need them anymore, I can just select them and delete them. I'm never going to be actually overriding the data unless I actually export the data and choose to overlay my annotations in the image export. The easiest way to do that is, like, let's say, for example, I wanted to grab a quick screenshot of this. I could just right click here and create image from view. This will create a new file that is not as big as my native file. And if I zoom in, I'm not gonna have that same resolution, right? I lose the ability to zoom in. But I have my current field of view with the burned in annotation in here, so that I could then save this file directly as a JPEG or as a TIFF or whatever other format. And that way get a quick image that I can paste into a PowerPoint or whatever it might be. So again, that was just by right clicking on the image and selecting create image from view. I'm also going to activate this tool for you up top, which will basically be the same option here, create image from view. We're gonna have it here available as a button. So again, if you're at a particular field of view, let's just zoom in into one region here. And then you click on that button. Again, it'll create a new file just in that region and with whatever annotations that you did burned into that. Okay, any questions about how to browse your data, how to annotate your data, some measurement options? Okay, you could also do some processing here again. So maybe you want to do an image export and you want to export your data as a TIFF or a JPEG, you can. I will definitely mention that these files contain obviously a lot of tiles and they can be very large. Zeiss handles them very efficiently by compressing them. I can show you here. This file is compressed to only 420 megabytes of hard drive space, but if it was uncompressed, it would be closer to 5 gigabytes for the full size. If you export as a JPEG or as a TIFF your full image, it'll be uncompressed unless you resize the quality here, which means that these files could be really, really big. So I caution you to not try to export a full region as a JPEG. Maybe it might be better to define a subset region and just select a particular ROI that you want to export. Or instead to do the use one of these buttons to grab just a quick capture of your particular field of view. It's not going to have all of the resolution, but it will be a manageable file size. All right, any questions about any of that? Okay. So now we're going to go into how to optimize scan profiles. So for that, I'm actually going to use this slide, and I'll start off with this one. We'll go through a full bright field optimization, and then we'll go into fluorescence. So like I mentioned before, to optimize a scan profile, I usually like to start with an existing scan profile and then adapt it. So we can start with this bright field 10x. We already run the preview, that's fine. What we would do is go here into the options menu and adapt selected profile for the scan of this slide. This is going to open the profile editor for us. In this U1, this was called the Advanced Profile Wizard. Now it's the Advanced Scan Profile Editor. The steps are very similar. Maybe we'll start from scratch here. we started here in the sample detection settings because we had already previewed the slide. But if you start from scratch, the first step is going to be the overview, which contains essentially that, just an overview of the profile. It will give you a quick idea of what you're using for sample detection, the coarse focus map objective, fine focus objective, scan objective, post-processing options, all of that. Then we have our label. So this is where we're going to capture the label for our sample. And essentially here, we just want to make sure that this red boundary box is actually around our whole label that we want to capture. So we can just maybe make a small modification here. I'm also going to optimize the exposure here for the label by clicking on measure. And then we can also rotate this label in a way that makes sense for us. So in this case, looks like a 90-degree clockwise rotation would put that the right up for us. And there's no barcode in this label, so I'm going to deactivate the barcode option. But if you did have a barcode, you could reactivate it here and it would read the barcode. That's pretty much for the label. The next step is our preview of our actual sample. And here we want to make sure that the preview area is just outside of the slide to make sure that we don't miss any part of it. And here the remote connection is a little bit hard for me to grab things and slide them, but I think I got it. Yeah. So something like this would be perfect. We can see all of our sections here. The two things that I would potentially optimize here, they're already pretty well optimized, but just to show you how I would do it, is just to optimize the exposure by clicking on measure and optimize the white balance by clicking on auto. And that's pretty much it. This looks good to me, so I can move on to the next step. These are our sample detection settings. So this is where we're going to set our threshold for tissue detection. And maybe I'll just play around with it a little bit. These particular tissue sections have a lot of contrast. So I definitely don't need to go, too far out into those lighter pixels that typically can pick up some more background. Perfect. So that works pretty well for this kind of application. I'm more limited here to the darker pixels thanks to the darker contrast that I have in this section. Okay, if I'm happy with this, then I can move into the next step. This is our coarse focus map generation. Typically for coarse focus, we want to use our 5x objective. And the coarse focus is going to be an absolute search between a given first and a last Z. So you have the option to enter these first and last Z values, and we're doing a full search through that whole range to determine the best place of focus for our sample. So I'm going to click on find focus here, and you'll see how the system basically scans very quickly through this 600 microns. And if we take a snap, it'll now show us the plane that it found as the best place of focus at 5x. Ideally, for most samples, you would want your plane of focus to be right in the center of your search range. That way you have the most room for error in both directions. So if, for example, the slide was a little tilted, or maybe the slide was a little bit thicker than normal, then this essentially accommodates for those differences to ensure that you can find your sample in that search range. And I typically recommend a range of about 600 microns. That should work for most tissue samples. And again, we're looking for the sample to be about in the center of the range, which is what it is. If it wasn't, it's a very easy adjustment. You can just adjust your first and your last. If you wanted to maybe move it a little bit up or a little bit further down, you can always make adjustments to this absolute Z values for your first and your last. You could also increase your search range in this way. So if you had samples that really had a lot of variability in Z, maybe like some really thick samples, like retinal hole mount, something like that. Maybe you might need to give yourself more room here. So then you might increase your ranges in both directions here and scan a bigger range. The compromise is this might take a little bit longer, but still it's pretty fast with the Axios Gen 7, so you wouldn't have to worry too much about that. Okay. Now, how many times am I going to do this step? That's determined by the support point distribution strategy. For most tissue sections, I recommend only doing this twice. The goal for the coarse focus, again, is just to find the approximate location of where your sample is located. At the end of this step, we're going to average the results from these two values and end up with only one final Z plane. So you can imagine that if I do this process here and I found this plane of focus 3974, and if I do it again, here, chances are it's going to be very close to that same value. So adding more points here is not really going to change that average. It's going to, essentially be almost the same. There's really no need to add a lot more focus points here for coarse focus, unless you were maybe scanning a section that was maybe the entire slide, right? And then maybe you needed a more representative sampling of the entire slide to find that Z plane. The focus map is generated individually for each tissue section. That means that we have 6 sections here. Total number of coarse focus points is going to be 12. So twice for each of these. Does that make sense? Any questions about coarse focus here? Okay. So once your coarse focus is set up appropriately, we can go into the next step, which is our fine focus. The fine focus should always be done at the same objective that you want to use for scanning. So if this is going to be a 10x scanning workflow, then this should be your 10x objective. You could always choose a different objective. So if you wanted to convert this into a 20x, you could always just choose the 20x here. And then that would carry over through the entire workflow in here. For now, let's just leave it at 10x here. And then what we would want to do here is, again, run the autofocus. That way we can verify that our search range here is adequate to find the focus, and we can take a snap to verify the results. That looks great. So here I had this 100 micron range, and the difference here is that this range is no longer an absolute search range between the first and the last Z. This is now a relative range with the starting center C of Z of my range being the average value that was found in the previous step, right? So again, in the coarse focus, we found approximately where our sample was. In the fine focus, we use that Z value as the center of our fine focus range, which is why this is a relative range. And this is going to be, again, created individually for each of these sections. For most applications, 100 microns should be more than enough. That should be plenty. This accommodates for now if the tissue section maybe has folds, maybe there's a bubble, maybe there's some excess mounting media. All of those things can change the focal plane. So this range here accommodates for those changes to ensure that I can find a good location to image each tile.
Hey, Sebastian, Anita has a question.
Yes.
At the top of your profile editor, there's a small button that says show all.
Yes.
When you click that, does it show this to look different than
Yes.
on course?
Mm-hmm. So the show all button here, it was activated here, which is how I usually run it. Maybe, obviously I'm more biased because I use this on a daily basis. If you deactivate it, you have a more simplified view, which basically just gives you the option of choosing your objective, Maybe for your channel, you have here the option to adjust your exposure if needed. And then you have here your search range.
Okay, so on the fine focus menu, we don't expect to see set first and set last. We only expect to see that on course. Is that correct?
Correct.
Okay.
Yeah, and I can go back if you want to see that. For course focus here, this is where we see set first and set last, because again, this is the absolute search range that we choose to search for our sample at 5x.
Okay, thank you.
Mhm. And if you wish, for most users, this might be a more simplified view, which is more streamlined, more user-friendly. So definitely feel free to use this initially. It might work for most people. The only options here that you don't have is the ability to change your focus point strategy. So I'll talk about what that is in more detail now. The focus point strategy, again, is to choose how many points to distribute and how. I'll show you here for this particular case, for this profile, I built my default focus strategy, which is onion skin 0.15 density, maximum of 45. So I'll show you what that means. I'm going to do that by grabbing my help menu icon from the top right. When you click on that help on the question mark, the question mark now follows your cursor. And if you click on any part of here where you are unsure about what it does, it'll open the help menu in that particular location. And it's very well indexed. It is very useful. So I highly recommend that you use this tool often. Again, you can use it wherever you are. It doesn't have to be in this wizard. It could be outside in Zen in any place. And it'll open further description of the option that you have in this view. So right now we're in our focus map settings. And then I can navigate here to our focus point strategy sets, which now explains in more detail how my focus points are distributed and the different options that I have to distribute those focus points. So the focus points are the distribution of points that I'm going to do around the tissue to automatically run the autofocus routine. And based on that, find the best place of focus for those specific points, and then interpolate for the tiles in between by creating this three-dimensional contour map of my sample. The system does all of this automatically. What I do here is I have the option to select how am I going to distribute those focus points and how many. So onion skin is a way of distributing those focus points where you lay out an initial layer of focus points following the perimeter of the sample, and you distribute about half of your focus points there. And then you take a step in, and then you distribute about half of the remaining points. And then you take another step in, and then half of those points, and then so on and so forth until you do all of them. This is my most recommended strategy for both bright field and fluorescence. It is really good at following the contour of biological samples and making sure that the entire tissue comes in focus. How many points is determined by the density and the maximum number. So the density here is a percentage. So for example, here 0.1 means 10%. So that's 10% of your total number of tiles will be focus points. So for example, if this tissue section was 100 tiles big, then 10% would mean we make only 10 fine focus points, up to a maximum of 24. So then we would be doing 10. But let's say, for example, this tissue section was 1,000 tiles big, then 10% would be 100. But if we have the maximum number of 24, then it would only do 24. So this is sort of a good compromise in between for different tissue sizes, in between a percentage and a maximum number. What I recommend as a default, again, is 0.15. I find that that density works well for most normal sized tissue sections. with a maximum of 24, 48, 50, 60, depending on the size of your tissue. If you want to be more robust about it, I probably would just do 0.15 with a maximum of like 150. And that way, you know, that profile is going to work for a lot of different tissue sizes, you know, from small to large. Where that could fail is if your tissue section is actually too small, and 0.15 would generate only, say, 4 or 5 focus points, fine focus points, then that focusing might fail because 4 or 5 points is not really enough to create a good 3-dimensional contour. And that sort of just has to do with how math, those polynomial works, those polynomial contours works, where like you need like a 6 or 9 degree polynomial to build a parabolic saddle. You know, it gets more complicated than what we need to dive deeper in. But in general, as a rule of thumb, it's nice to have at least 6, if not 9 fine focus points. So if that's the case for your smaller tissue sections, I would recommend increasing the density here to 0.2 or 0.3 or even 0.4, just to make sure that you have enough fine focus points. The other strategies here, every nth row and column, this is also very used. It creates this sort of like grid pattern on your sample, which can work very well as well. So this is my second favorite choice here. And there's a few other ones here. I typically don't use every tile. That usually is overkill. You also have this grid option. There's a few here, so feel free to review them. But again, the one that I recommend the most is onion skin. We can always now verify with SIM 3.4 how those points are distributed and how many. So I can see here that I have this. Each tissue section has 1, 2, 3, 4, 5, 6, 7, looks like 9 at 10x, which makes sense, right? The 10x is fine. And I always have the option of editing those points right here if I need to. Okay, any questions here about the fine focus point? The coarse and fine focus are really the most important steps in the profile. So no question is a bad question here.
Sebastian, would there be more focus points if you did the 20x, or it'd be the same number?
There would definitely be more focus points if this was a 20x profile, because it would be essentially 4 times as many tiles. Okay. So that means that 0.15% would 0.15 or 15% would lead to, you know, probably, you know, 4 times as many points as we have here.
Okay.
Just
Thanks.
one more question, Sebastian. I think it'll be good to have it in this video, but just to clarify, when the Axioscan actually scans a sample, it uses just one focal plane for each sample, correct? This is just going to get a number of points from which to average?
No. That is true only for the coarse focus, where it averages both points to find the starting z-plane for your fine focus. But in the fine focus, all of these points are going to have their own z-plane that is going to then be used to build a 3-dimensional contour, an nth degree parabolic saddle, where it is going to interpolate in between all of these points to determine the best plane to image every tile in between points.
And that was true on our old scanner?
Correct.
And we had the wrong model of how it worked. Thank you.
So no problem.
Yeah,
it's a little bit tricky to explain and to like really understand. It took me a while, but yes, that's essentially how it works. The coarse focus is essentially a flat plane with just one average value. The fine focus is a parabolic saddle nth degree polynomial, depending on the number of fine focus points that you have, which also is why I recommend always having at least 6, if not more, if not 9 at least, fine focus points, so you do have a good distribution of points.
But then when it scans, in the final scan, if there's 400 tiles, it's possible that the Axioscan might have used a different focal plane for every tile. Is that what you're saying?
So that's why the density here comes in play. So imagine that this was just a 0.1 density and we had 400 tiles, then it would do 40 points. And it would distribute those 40 points, around the sample. And then that doesn't mean that it's, focusing on every tile, but it's going to use those points to determine how to interpolate it between points to find. Yeah. So if two focus points end up returning the same Z-plane, ideally if the sample was perfectly flat, that would be perfect. Then every tile in between would be scanned at that same Z-plane. But if one point was higher than its neighbor, then the AxioScan would basically draw a straight line in between the two and take every tile at a slightly different step to follow the contour of the sample.
Yeah, the AxioScan actually moves the objective to get a different, possibly focal plane for every tile to be in focus. Got it.
Yeah.
Thank you.
Okay. I'll just give a couple of quick notes here on how to optimize this if needed. If, for example, your scan came out completely in focus, like not even close, you can maybe like see sort of a border of it and that's it. That usually means that your ranges need to be optimized, either the coarse or the fine focus range or both. That means that the ranges are not reaching your sample. So that is where you would go back into the editor and try a few different ranges, run your autofocus, and make sure that you are being able to find focus with your given range. If the issue was that in your tissue section, some tiles are nice and sharp and some of them are pretty far off, even in neighboring tiles. That usually means that your focus distribution strategy for fine focus needs to be optimized. And maybe we need to do a different kind of distribution, or maybe we need more points to be distributed. Does that make sense? Okay. If you're happy with the focus point distribution strategy, then we go to the last step, and now this is pretty easy. All we want to make sure is double check that our objective here is the same one as selected before for our fine focus, right? That's the same one that we want to use for scan. And maybe we might want to check for bright field images, our exposure and white balance. And we do that by going live and actually stepping away from our tissue into an empty region of the slide. And what we want to see is just like here, that our three peaks are all aligned. That means that we're white balanced and all at the very edge of my dynamic range. That means that we're properly exposed. If this wasn't the case, it's very easy to fix it. What you would do is click here on measure, and that would automatically measure the correct exposure for this objective. And we would also go here under acquisition mode and white balance here, auto white balance. So this would be the two steps that I would do if I noticed that my balance or my exposure was off. And again, they're automatic routines and they should be able to find this nice balanced exposed image, again, in an empty space, because I want to have that white reference essentially. Okay, that's really it. That's all that we would have to check here. We do have the option here of adding a Z-stack. When would it be appropriate to add a Z-stack? There's two main instances for this. The first one is our tissue section is thick. So as opposed to maybe the standard 4, 5, 6 microns, maybe our tissue section is 10, 15, 20, 50. If we needed to capture all the data from the entire sample, then this means that we would probably need to create a Z-stack. As a rule of thumb, typically when I create a Z-stack, I aim to have a range or a total thickness of Z-stack, that's about half of my tissue thickness. So for example, if my tissue was 20 microns, I would aim to have a 10 micron range, which is easily doable here by setting your interval, and let's say 10 slices at 2 microns per slice, that would cover 20 microns. Oh, what did I say? My example was it 20? So then I only need 5. Let's say my example was 20 micron tissue thickness, then I would aim for a 10 micron Z-stack. And that's a rule of thumb that I find that usually works for most samples. If you wanted to actually verify the range that you need, what I would do is go live. And if you go live and press Control on your keyboard, you have control of the Z plane in the microscope. And if you use the scroll wheel on your mouse, every scroll is 1 click here. And by default, it's set to medium. So every scroll here is 4 microns. So I can go through and scroll through a few clicks, and I'll notice, right away if I'm already going out of focus in my sample. So that could help me determine how far in each direction do I need to go to capture everything. And then I just add those values to determine my range. I can also pay attention here on my focus plane. And maybe a better way to do this is, maybe zoom in so you have a better view. And maybe you might want to not scroll at 4, but maybe 1 micro at a time or 2 micros at a time. So you can really critically analyze how thick of a sample you might need to grab. Okay. Once you determine that thickness, then you can sort of calculate here how many use slices you need at a specific interval, which for the 10x, I typically recommend 2 microns. For 20x, I typically recommend 1 micron. The second instance where you might need to add a Z-stack is if you are imaging at 20x, more likely, and you are trying to capture signals that are really tiny. And I'm talking about subnuclear level of puncta. So for example, if you're doing FISH or if you're doing chromogenic-ish, in situ hybridization, those signals tend to be really small and you might miss them if you're not in the exact plane where they are located. So in those instances, maybe a Z-stack would help. And in that case, you really need just a very short Z-stack with the optimal interval, which is going to be probably smaller. So for 10x here, the optimal is 1.81. I think for 20x, the optimal is, 0.46 or 0.5. And then you only need maybe, 3 to 5 slices at most, just to make sure that you're scanning the entire thing and not missing any of your samples. And really the way to determine that empirically is by just running one scan without the Z-stack, and then running another stack with that Z-stack, and then you can compare and see, is it really beneficial to capture that extra data? Do I really need to do it? Obviously, adding a Z-stack will increase your file size and your scanning time. So obviously, only do it if it's really necessary for your sample. Now, if you do a Z-stack, you have the option of either capturing all planes and the final file having, in this case, 5 planes. So the file size is going to be about 5 times as big. That could be useful if down the road you want to be able to scroll through the Z-stacks, or for example, in Fluorescence, if you want to use deconvolution, you need to have all the slices separately. However, if all you want to do is capture all of the data and visualize it together, you might want to then activate EDF, extended depth of focus, which will compact those 5 planes back into one single plane automatically for you as soon as the acquisition is done. That way, the final file contains only 1 plane as opposed to 5. If you do this, you have a few options on the method to use for the EDF. For bright field, I would say the most used ones are variance and contrast. For fluorescence, typically contrast or maximum projection are the most used. And the best one is really going to depend on your particular application. So I recommend that you just test out a couple of them until you find the one that works the best for you. Okay, for now, I'm going to deactivate these options. And then I'll just mention real quick that by default, we do stitching online, which means that the system stitches as it scans. If you have non-continuous tissue, for example, you have cells, or you have like a blood smear or something like that, then maybe offline stitching is more robust because it waits until all the tiles are captured and then it tiles all tiles together using 4 borders. If you do online stitching, this works really great for tissues. It stitches as it scans, only using the 2 borders that it has to compare, the left and the top borders, right, from the previous tiles that were captured. And then by default, we have JPEG XR 85% compression. It's a lossy compression, but it definitely keeps more than enough data for most applications, and it really reduces the file size quite a bit. Okay, any questions here about scan settings, online processing, Z-stacking? Okay, so we can finish the profile here. It's telling us that we did a preview and we made some changes, so it's going to clear the preview. That's fine. Okay, and then here, again, like you noticed, it'll give you the option to save this profile, adapt it for this particular slide, or you can override the previous profile by just deleting that, and it will ask you if you want to override it. I think in this case, I don't know if we make any real adjustments. You can override or not. The profile didn't change much, but this is how you would then save it, with your own name. That way you're not overriding someone else's profile or the default profiles, which I recommend that you keep sort of generic so that they can work for multiple different applications. And then you would obviously test the profile by, running the preview or starting the scan, and then, scanning your entire tissue section. Okay. Any questions there about profile editing? So at this point, this is a good spot to take like a 10-minute break. And then when we come back, we can go into how does this profile editing translate into fluorescent imaging. Does that sound okay?
That sounds great. Thanks, Sebastian.
Okay. All right, so let's resume at 3:35.
Okay.
Okay, is everyone back?
Well, I'm here, Anita, Gio. I got a thumbs up from Juliana. All right, let's do it. And Lynn, okay. Cool.
Awesome.
Anita was just saying how great this is, and this is, yeah, we're still recording, so we should be good to review back too. So thank you so much.
Sure. Okay, excellent. So
And-
now let's go. Oh, yes, go ahead.
Oh, I was saying, and apparently Gio's slides will be really pretty looking in fluorescence.
Okay, great. Excellent. Is there a preference between these two? Of which one to use?
No.
Okay. So let's go into fluorescence.
Preference?
No, no preference.
And what we'll do is
Do you think you'll need
I
to-
created some shading corrections for you already at both 10 and 20x. I'm going to use this profile that I created to shading corrections as a baseline to create a new standard profile for you for your fluorescence options. The workflow is going to be the same. We're essentially going to select this starting profile and then adapt it by going here under Adapt Selected Profile. This is going to open the menu again through the same 7 steps. I'm going to go a little bit faster through the common steps that we already did for Brightfield, and I'll dedicate more time to the actual fluorescence components. So same thing here for our overview. We don't need to make any changes here. It's just letting us know what this profile is set to do. Just letting us know what this profile is set to do. Then we have here our label. So we're going to capture our label here for this particular slide. I don't need to rotate my slide at all to read it properly. So I'm just going to select here no rotation or original, I think. Okay, good to go. And then we have the preview of our tissue region. And I'm just going to, again, increase this a little bit to make sure that I don't miss out on any tissue sections. And I'm going to optimize my exposure and white balance. Okay, now we have our sample detection settings. For fluorescence, these can be tricky if the samples don't have any colorimetric contrast. However, we do have a trick here that we can use. Since it seems that these samples have some contrast, what I can do is enhance here my display adjustment. And now I can see my samples pretty clearly. And I doubt that the automatic tissue detection will be able to pick them up. I can try. Let me really open up this towards the brighter pixels. Ooh, okay. So it picked up a couple of them. I'm really pushing it because I'm right at the border of my display histogram. So I doubt that I'll be able to really pick them all up. It did okay. I wouldn't say it's the best, but for something that's traditionally so tricky, I think it's actually pretty good. However, my recommendation would be to just forego the automatic tissue detection altogether, because here it's easier to just draw some shapes like I showed before. So I can just pick my spline contour and sort of draw here by clicking around the borders of my sample. Okay, and again, if I mess up somewhere, I can edit the points. Maybe move this one here a little bit further in. Perfect. Or the other thing that I can do again is grab that area and I can copy and paste it into a new one. That is something that you would do in the actual scanning workflow. Again, in step number 5 of your scanning workflow. For now, I'm just going to leave this one selected to set up my profile. And I'll show you how to maybe change your tissue detection for the actual scanning when we go into the scanning workflow. For now, I'm going to go into the next step. And then I have this set up in here to do our coarse focus using DAPI. Let me check here how bright our sample is. I'm going to take a quick snap. I haven't focused or set up my exposure. I just want to sort of visualize where I'm at. Okay, it's actually pretty good. So what I want to do here now is optimize my exposure settings. So I'm going to run my autofocus to find the actual plane where my sample is. And then I'm going to click here on set exposure. This set exposure here is aiming to fill only 20% of my dynamic range. That's what this intensity value here means. And basically, I'm just doing this because I really don't need a lot of signal to find my sample. And this is not how my picture is going to get captured. This is just for focusing. And this is really all I need just to get an approximate idea of where my sample is located. Ideally, what I would like to have in here is a very gentle LED exposure power. I can maybe go lower on this and have a slightly higher exposure time. That way I can be very gentle on my sample and illuminate with a low exposure setting and a fast exposure time so I don't cause any photo bleaching. So this is sort of my goal in this step. One thing that I had pre-built into this profile to help me with this is I included binning. So if you go here under acquisition mode and binning, I'm binning 4x4, which means that a 4x4 array of pixels, so 16 pixels are getting pulled together into one. This essentially increases the sensitivity of my camera so that I can get a good amount of signal with a very low exposure time. So this is great for focusing. I'll show you as a comparison. If I wasn't binning and I take the same snap with the same settings, my signal went really, really far down, super, super low. So again, binning is just allowing me to increase the sensitivity of my camera for the focusing. Perfect. Same thing here applies, an absolute search range between the first and the last Z-plane, and we want our sample to ideally be very close to the center. So this is optimized. I'm doing a smart search, which means that I don't search through the full range. It only starts in the center and oscillates around until it finds the place of focus. And this often works really well. And will allow me to do this step much faster compared to running a full search, which would go through the full range top to bottom. And this can take longer. However, the full search is more robust. So if you notice that you're having some issues where your images are coming out of focus, the first thing that I would change is go back to the full search. But for most applications, hopefully smart search works well. Same thing here with the number of points. I only need to do this twice here for coarse focus, and then I can go to the next step. Again, in fine focus, all I have to do is optimize my exposure settings for my channel. So what I'm going to do is run the autofocus. And I can take a snap and see what the signal looks like. Okay, I definitely have too much signal. I don't need all of this signal. I'm going to go way more gentle here on my LED power and set exposure here. Perfect. So now I'm aiming to fill again just 20% here on my dynamic range. That's definitely enough to focus on my sample and not cause any photo bleaching. And I'm also binning here. Only 2x2 is really necessary. The 20x is such a good objective that binning 4x4 would actually be overkill. Same thing as before. This is a relative search range. 100 microns should be good for most applications. I'm also doing a smart search here. Again, if you're seeing your focus failing, I would switch that to full search. And same consideration applies as before to the focus strategy. For these tissue sections, I actually think that 0.15 with a maximum of 48 is probably a good place to be. So I'm just going to leave it as it is. Again, the only differences that I've done so far is I have to optimize my exposure settings in a fluorescence channel. Everything else has been very similar. Now, in the last step, this is where we're going to see more differences, because this is where we're going to choose the channels that we want to use to image our sample. So this is again a 20x profile. So I have my 20x selected. I actually don't want to do binning here because binning, even though it increases the sensitivity of the camera, it does lower its resolution capability. So for the actual scan, I want to be in just 1:1 binning. So no 2:2 or 4:4 binning. And then for my channels, what I did for you is I created essentially one channel for all filter options that you have available on this system. So this system actually has a few single band filters and 2 multi-band filters. Now, what's the difference? So multi-band filters are capable of imaging multiple channels with the same filter by only adjusting or selecting a different illumination LED for each channel. So for example, filter set 112 over here is capable of, it's a 5-band filter. So it actually has 5 discrete bands that it can capture. And it's capable of imaging DAPI, GFP, or equivalent dyes like Alexa 488, Psi3 or 555 and 568, Psi5, which is equivalent to 647, and Psi7, which is like a 750 near IR wavelength. So this same filter cube can image all these 5 without needing to change my filter. And what happens is instead for each of these channels, a different LED turns on. So for DAPI, you're gonna get an ultraviolet LED. For 488, you're gonna get the blue LED. For Psi3, you're gonna get the green LED. For Psi5, you're gonna get the red, the orange, so on and so forth. So if you use multi-band LEDs for all your channels, you're gonna have the fastest imaging possible because the system doesn't need to change the filter turret around, which adds more time to your scan. So you're always going to be imaging faster if you can image with these channels with multi-band filters. The second multi-band filter is capable of doing CFP and M-Cherry. These are less common dyes for most applications, but they are often found in some expression studies. Or M-Cherry is also a 594 Alexa, which can also be fairly popular. Now, the only disadvantage of multi-band filters is if you have fluorophores that have really long tails, are really close together, and tend to have crosstalk or bleed through, the multi-band filters can have more crosstalk or bleed through. In those cases, if you really need to separate the signal, then you would need to use one of these single band filters that can only image one color at a time. So you have one filter that can do GFP, one that can do DS red or its equivalent 555 or 568 Alexas. You have the filter set 50, which can do 647. Filter set 90, this is a rather uncommon filter. This one can do CFP essentially. And it's also a pretty broad green as well. And then BFP, which can also do DAPI. My recommendation, if you need to use single band filters, is to perhaps use the multi-band filters for your well-separated signals. So for example, if you had DAPI 488 and 647 in one single stain, actually let's do 555 and 647, so all those 4 colors. Maybe there might be some crosstalk between side 3 and side 5, right? That 568 and that 647 channels. If that's the case, what I would probably do is maybe image DAPI and 647 with the multiband because they're well separated. We're not going to get crosstalk in between those two. But maybe then image my 488 and my 555 with my single bands. And that would sort of be a good compromise where I can benefit from the speed of the multiband for 2 channels, and then I do 2 channels specifically if needed. I don't recommend using this BFP filter for DAPI. It doesn't work very well. I would definitely recommend using the filter 112 for DAPI at all times. Now, what I did for you to help you with that setup, so you don't have to go in and go into the light path and select filters yourself, is I built channels according to the filters. So I have the same channels here for your filter. So this 488 uses that single band. This 555 uses the single band. 647 the same. This 430 the same. And then for the multibands, I labeled them with the name of the multiband at the end. So filter set 91 can do, like I mentioned, CFP and 594. So these 2 channels have that same filter selected here, filter set 91. And then towards the end, you have filter set 112, which, like I mentioned, can do these 5 colors, DAPI 488, 555, 647, and 750. So then for your own applications, what you need to do is then go in here and deselect the channels that you don't need. So for this sample, I think we had DAPI 488, 560 something, and 647. Is that correct?
That's correct.
Okay. So in that case, I'm going to do as an initial try to image them all with my multiband filter. So that would be really fast imaging. So I'm going to leave only selected those 4 channels with my multiband. So DAPI 48, 555, 647. This channel, even though it's called 555, it can image 555, 568, 547, all of those in that same side 3 range. They all use the same filter. Any questions about the difference here between single band and multiband filters, when it's better to use either, and how to select them here in the setup? Okay. So now I'm going to show you how to optimize the exposure for each of these channels. And here, maybe I'll need your help from whoever samples this is to navigate to a region with positive expression. You can do that by clicking on the sample here if you know already where the positive expression might be. If not, we can do it wherever. Ideally, you would want to navigate like I'm doing here to a region of positive expression. That way you can set your exposure settings to your positive signal. Otherwise, if you set it in an area of negative signal, when you actually reach the positive signal and you scan with the same exposure, you're probably going to be overexposed.
Okay.
Yeah. He wants to click in the cortex, but I told him he could click.
Oh yeah, go ahead and click. Okay. So what I'm going to do here is in that region, I'm going to have to focus right on that region because I was focusing the center, but not there. So I'm just going to run the autofocus. Okay. And now that I'm in focus, I'm going to go one channel at a time through all of these channels and optimize my exposure settings. So my exposure is going to be a combination of my LED power output and my exposure time, like I mentioned before. For most stains, I would recommend for DAPI, typically we can get away with 20 or 30% LED power output. And let's set our exposure here. 7 milliseconds, that's great. Oh, and actually I don't need 70% shift. So all of these channels actually had been corrected to 70% because that's what was needed for shading corrections. But for actual imaging, we recommend only 30%. So 30% is all that you need. And maybe what I'm going to do is I'm going to change that for all of the channels. That way it's already built in there and you don't accidentally set 70% shifts, because that would that could overexpose your samples. And what this means is 30% is aiming, when you click on set exposure, it's aiming to fill 30% of my dynamic range. So like about from here to here, like 30% here. This is more than enough pixels for your image to capture. And it also leaves more than enough space so that if there's a region with more positive signal, you can capture it without being overexposed. So this is the recommendation for whole slide wide field imaging, that you capture with 30% shift in your dynamic range. And that's what this value here will automatically aim to do when you click on set exposure. So I'm going to quickly just change that for all channels to 30%. That way is set there and ready for you. That way it's you don't have to change that later. The other thing that I'm going to change here for all channels, besides setting the 30% exposure, or shift setting, I should say, is I'm also going to activate the shading correction, which I created for you. And essentially what shading corrections do is they flatten out the illumination field. They make sure that there's no uneven illumination, so that at the end, you don't see any like tiling in your image. That's typically due to some uneven illumination in how the light is going through the filter and through the light path. And a shading correction fixes that. I already created it. We just need to apply it for all channels. So I'm going to go here for shading and click on user because I defined it already. So just make sure that when you're actually scanning, your channels have that user shading correction selected. Never, ever, ever, ever click on this. Don't click on define. It'll take a picture wherever you're at with whatever features and contours it finds and create a shading correction based on that. So then moving forward, your images might have some weird random tappy and spots in them at random locations. This is useful for other workflows, but definitely don't click on that for normal workflows. Okay. All right, now that this is done, hopefully you won't need to ever go back in here to do all of these. They're sort of gonna be ready here for you. So all you would have to do is, again, select the channels that you want to use and set your exposure times. So I'm gonna, again, go ahead here through these ones. For 48, typically 30 to 50% LED power is a good place to be. That's great. Let's look at our 555. I'm gonna set this also to 50% as a starting guess. It's pretty good. And then this is our 647. That's excellent. So now I have more. Mm-hmm.
Oh, sorry. A question about the intensity. So on our Axioscan Z1, we have a HXP lamp.
Mm-hmm.
And so we were taught to always keep the intensity the same so that it wasn't changing.
Sure. Yep.
Yeah. But that's not true anymore with the Calibri.
Correct. No. So for the HXP, since it uses the same illumination source for all channels, then it was useful to keep the same power for all channels. That way, you didn't have to try to change powers in between channels. Here, the Colibri has individual LEDs for each channel that it can trigger individually. That's what allows us to use these multiband filters. So because of that, you can set individual LED powers for every single channel if you wish.
Awesome, thanks.
Okay, now that I set my exposures, I'm going to take a snap so I can visualize how that is looking. Okay, so I have here my 4 colors. They all have approximately 30% shift. So that's what I was aiming for. I can look at each individual channel. If I go here under dimensions, single channel, and that way I can toggle between them to sort of confirm. And that way I can also get a quick idea of how my signal is looking here. I can further adjust the display adjustment if needed, so I can maybe look at this a little bit brighter. And it gives me a chance to sort of double check that, you know, I'm seeing what I'm hoping to see, right? For the red and far red, a good way to check if you have any crosstalk or bleed through is to essentially just toggle in between these two and see if the signal is going from one to the other, if I see repeating patterns. But for the most part, it actually looks pretty discrete. So this tells me that perhaps I can use my multiband filter because I don't see actually that much signal crossover in between the two channels. If you wanted to be more careful about testing this, you could always activate one of the single band filters, like for example, this 555, take another snap. Oh, I didn't set the settings for this, so it's going to be overexposed. Oh, actually, it wasn't that bad. Okay, let's do that again. If you want to be careful about comparing, then what I would do is do this, and then you can again do single channel, and you can toggle in between the single and the multiband and really see if there's any differences in between the two. If you see that the multiband has some further structures that are not in the single band and perhaps are also in the far red, then that would be a giveaway that the multiband might be capturing some bleed through or crosstalk. Here, I don't see anything. They look exactly the same. So to me, this verifies, okay, I can confidently use my multiband and my signal is well separated. Did that make sense for everyone? Okay. The last thing that I'm going to do is you'll notice there's a channel here that's selected as my focus reference. This is actually for focus and stitching. So we need a channel for stitching. Typically, that's going to be our counterstain, DAPI. And I want to make sure that this is selected as one of my active channels. Otherwise, the system would reactivate this channel for me because it needs it to stitch. So I'm just going to make sure that I go here and select my counterstain and select it as my focus and stitching reference. That way I know that it's going to be used to stitch my whole image. So now this profile is optimized to image these 4 channels with the exposure settings appropriate for this particular sample. Any questions about that?
I have a question about the exposure time. So this is not something that we're ever adjusting ourselves, right? That we'll manually adjust. It's something that will.
Sorry, I can't quite understand.
Oh, sorry. So for the exposure, when we set the exposure, that's something that we trust the system to do pretty readily, correct? By clicking set exposure. It's not something that we're going to manually adjust ourselves.
You could always manually adjust it. So you could say like, okay, I always like to capture this at 5 milliseconds. So you can definitely set a manual exposure if you want. That's an option, and you can capture, you know, all of your feature sections with the same manual exposure setting. That's also an option.
Okay.
I typically go with the set exposure just because, again, I'm aiming to fill this 30% of my dynamic range, and it's you know, sort of an automated optimization, I would say.
Right. Okay.
Okay. Same thing here about Z-stacks applies as before, so I'm not going to go into too much detail here again. And again, here for processing, we recommend online stitching, pyramid active, JPEG XR compression. of 85%. This is all going to be saved in this profile. So, don't worry about, having to do that yourself. I'm going to save this as a master profile for fluorescence. It's going to have these 4 channels, but it has all the other channels already also pre-built in. So if, for example, you have a 594 line, you could also use activate it here. Or if you want to use one of the single band filters, you also have it available for selecting. The last thing that I will note is if you want to change the pseudo coloring of your channels, you can. I typically don't like this orange and red combo because it's super hard to distinguish. I typically like to have 555 in red and 647 in violet. But feel free to change it to yellow or white, whatever you would prefer.
Could I jump back real quickly and ask a question regarding the exposure, set exposure?
Of course.
So the question is, if we manually wanted to set exposure for each channel and we want to apply that same profile to other sections, and would that set exposure, like that manually typed in number, be propagated when you apply that same scan profile to
Yeah.
other? Okay.
Whenever you have a final value here and you exit the editor and you save it, this is the value that will be used every single time that this profile is called into play.
Okay, great. Thanks.
Okay, so I'm going to go ahead and finish here, and I'm going to save this with a new name. This profile is no longer shading corrections profile. It's actually going to be our default fluorescence profile. So I'm going to save it here with fluorescence 20x. And this one particularly has TAPI 48, 555, 647. But again, feel free to start with this one and select other channels if needed for your applications down the road. I'm gonna go ahead and save it. And now let's test it out through our 6-step workflow. So first step was to choose the profile, it's already selected. Second step, choose the naming definition, let's just go with that. Third step, the storage location, we'll put it in the training, that's fine. And fourth step, we're gonna preview the slide. Now, because of the way that we're doing the tissue detection for this fluorescence sample, we are going to go into the 5th step to check the tissue detection and draw the regions that we want to scan. Okay, it's saying input required because obviously it couldn't detect anything that's expected. So again, we're going to go into the check and correct sample detection results. And I'm actually just going to select a small region here. I'm going to enhance my contrast here. And just select a small region here to scan. Again, I can choose to visualize cores or find focus points if needed. This is a pretty small, this is a really tiny region. I'll maybe make it bigger. It's so tiny that the 0.15% is only adding 1 point, which again would be a failing focus strategy because you can't build a 3D contour with 1 point. You can't even build a line with 1 point. So maybe let me go here and I'll make it a little bit bigger. And maybe what I might do is manually add more points to adapt this focus strategy. These sections are very small, so it might be useful to increase the density from 0.15 to maybe 0.2, 0.25. Let's see. Yeah, not quite enough points. Okay, we can go back in the profile and maybe add the, increase the density of points. So we have a few more, but for now, I'm just gonna manually insert a few more. And that's 6, that should give us something decent, even if it's not perfect. I'll just start the scan. Did that make sense? Why I would suggest for these smaller sections to have a higher density of points in my onion skin distribution strategy for fine focus.
Yeah, that
Or
makes,
also,
is it the same on the Z1? Do you know?
yeah,
The
exactly the same.
focus points? I never saw that before.
Yeah.
Okay, cool.
So it's scanning now. I can quickly double check how it's coming out by enabling acquisition monitoring. Okay, perfect. So yeah, it looks in focus for the most part. Okay. Could probably still add a few more focus points, but that was pretty quick. So like, as you can see with that multiband filter, the imaging is ultra fast. It only took not even a minute and a half to scan those styles.
Wow.
Okay. So this is what I like to see in terms of shading corrections. I don't see any tiling. I can go channel by channel to confirm, but I don't see any grid lines. So that means that the shading corrections that I created for you are hopefully going to work for many different applications. There are some that might need their own specific shading correction. And then at that point, we can go over how to create individual shading corrections for particular challenging samples. But it looks pretty good. This was, let me see how many tiles. This was 40 tiles that were capturing those like less than a minute and a half, something like that. And we can always zoom into particular regions and see. We can adjust the display setting here to maybe optimize the display a little bit. The right side basically enhances the brightness. The left side enhances sort of the contrast. Oh, okay, interesting. So I see also that in this channel, there's some signal that's in a different plane. So this could be a reason to do a Z-stack for this sample, because not all of my signal is in the same plane. So a Z-stack could be useful here to capture all of it, because I can see that most of my nucleus is in focus. So the focus strategy is working because it was designed to search for the nucleus, but my green signal is clearly slightly different plane. So I would need a Z-stack to capture it. The red looks pretty good. I'm gonna enhance here the contrast a little bit. Maybe actually I need less enhancement of my brightness so I can see more of those details.
Red is the microglia.
And then far red, I can see a few points here and there. Okay, that looks much better. Okay, and then I would basically just maybe with the navigator open, or by just clicking around, we can confirm a few different locations here. Maybe let me bring this down a notch here. Okay. Could probably optimize my focusing strategy a little bit better. For these small samples, again, I would recommend maybe a higher density so we can have a few more fine focus points distributed. But for a first pass, I would say it worked pretty well and no shading issues. So I think you're gonna be good to go with this. What do you think? Any comments, questions, concerns?
I think it looks good and fast, so fast.
Yeah, it is really fast. The multi-band filters are really a game changer. Okay, so this covers everything that I wanted to go over in our initial training session. What I can do is, you should definitely try it out yourselves, try a few different applications, try to optimize your own profiles. Again, you have a starting base for profiles, both for bright field and now also for fluorescence that you can use. This is a 20x fluorescence. You can also adapt this one for 10x fluorescence if you wish, in the same way that I just did with you today. And then we'll have probably a follow-up session in a few weeks to go into other workflows as needed once you have some questions and are ready to learn about more complex workflows on the action scan.
Thank you very much.
Of course, you're welcome. If anything comes up, feel free to reach out and let me know.
Great.
Thank you, Sebastian. This was really great. We're excited to get using it, and we're starting to use the CD7 too. So
Awesome.
we have so much data soon.
Yes, that's great.
And we definitely will need to follow up with you on that one for sure, for the whole processing workflows and stuff. But
Sure.
maybe a little while out yet.
Definitely. Okay, excellent.
Thank you.
Thanks.
Thank you.
Thanks, everyone. Have a good day.
Thanks, you
Thank
too.
you.